Good day, my scholars. This is my school channel and my name is Abiola. For this video lesson, you'll be joining me to tackle the JAMB CBT past question for the subject Mathematics, the year 2008. Do not go anywhere, stay with us and we'll be right back. Welcome back to my school YouTube channel. Right there, you'll be joining me to solve the questions 18 to 33. So join me as I begin with question 18. Solve the quadratic inequalities x squared minus 5x plus 6 is greater than or equal to 0. So let's rewrite the inequality. Alright, so what we just need to do is to factorize. Okay, so the factors should be, alright, what we can add together that will give us minus 5x and what we can multiply together that will give us plus 6x squared. Alright, so what can we add together? This should include minus 3x and minus 2x, because minus 3 plus minus 2 gives us minus 5. Minus 3 times minus 2 gives us this, alright? Minus times minus plus 3 times 2, that is 6. You can see, so that is very valid. So that means the factors are this, right? Because if you expand this, you should give us this. Alright, so that is x minus 3 equals 0, or x minus 2 equals 0. So you can add positive 3 to both sides, or you can send this 3 outside. You can add positive 2 to both sides, or you can send it 2 outside. So I have x equals 3 or x equals 2. Alright, for this particular expression, so the appropriate thing to do should be x is greater than, right, or equals to 2, then x is less than or equals to 3. This implication is that the value of x can be 2 exactly, or something like 2.1, 2.2, 2.3, 2.4, 2.5, right? Then it lies between 2 and 3, the values of 2 and 3. So this is the right expression. X is greater than or equals to 2, or x is less than or equals to 3. So this should be a very good compilation, depending on how you want to express, but it's very accurate. So let's go back to the screen to select the right expression. So I have x is less than or equals to 3, and then I have x is greater than or equals to 2. That means the values of x lies between 2 and 3. So option B is good to go. Question 19. The fifth term of an AP is 24 and the 11th term is 96. Find the first term. Okay, so we just have to express this in equations, right? So we are told that, remember the formula for AP plus n minus 1, right? Then into brackets D. Right here we are talking about the fifth term. That will be 5 minus 1, right? Into brackets D, right? The fifth term. Right? So that should be T5. Should be written as a subscript, please. Right, so that means the 20th term will be T20 equals A plus 20 minus 1, that is 19D. Do we see that? So this is just, okay, so we are told that the fifth term has the value 24. Okay, so this implies 24 equals A plus 4D. Alright, then we have the 11th term is 96. So 11th term, that is 96 equals A plus, remember 11 minus 1, that is 10. 10D. Alright, so I can use elimination method, I can use substitution method. Alright, so let me say minus affects everything right here. So let's just minus them. So 96 minus 24, 6 minus 4, that is actually 2. 9 minus 2, that is 7, equals A minus A, that is 0. 10 minus 4, that is 6. D. So we divide both sides by the coefficient of D, which is 6. Right, so I have it right here. So 6 here 1, 6 here 12. So D, which represents the common difference, that's 12. So since the common difference is 12, I can pick any of these equations, right, to find the value of A, given that D is 12. So I can make this happen by saying, I can use 24, T5, okay, 24 equals A plus 4 into bracket the value of D right now, that is 12. So I have 24 equals A plus 4 times 12, 48. All right, so I can send this outside. Okay, so I have 24 minus 48 equals A. 24 minus 48, that's actually minus 24. So the first term is actually minus 24. So let's see if we have this value. Supply in the options on the screen. Yeah, we have a confirmation. Option D, minus 24, is the right expression. Number 20. A binary operation is defined on a set of positive integers, which is 2x minus 3y plus 2 for positive integers. Positive integers. 1, 2, 3, 4, 5, not minus 1. Positive integers. Okay, x and y. Alright, so the values of x and y should be positive integers. Okay, so the binary operation is what? Okay, so we should note this. When it comes to positive integers, we know that the property is applicable for closure, right? Okay, under addition and multiplication. Okay, it doesn't work for subtraction or division. All right, it's going to work for subtraction if the value of x is bigger than y. All right, so like for instance, if you try saying, let's say x is 1, y is 2, right? So anywhere I see x, I replace it with 1, see y, I replace it with 2. So try doing this. I have 1, right? 2 times 1, I have 2, right? Minus 3 times 2, that is 6. So 2 minus 6, that is actually what? That is minus 4. Minus 4 plus 2, that is minus 2. So you can see, we do not come by positive integers. So you can see it's not applicable there. All right, so we know this is not closed. All right, let's sort for commutative. Commutative means that even if you switch the values of x and y, okay, you should still have the same results under the condition of being positive integers, right? So if you look at this, if I flip the values of x for y, let's see if we are going to have the same thing or vice versa. Okay, so let's try that. So we accounted for 1, or we recommended 1 for x, and y 2, right? So we got a minus 2, isn't it? So let's try imputing this here. X as 2, then y as 1. Okay, so we have 2, we have 1. So 2 times 2, I have 4, minus 3 times 1, that is still 3. So 4 minus 3, you can see that is actually 1 plus 2, that is 3. So you can see that when the value of x is 1, value of y is 2, the answer we got is minus 2. When we now flipped or switched or exchanged their value in commutative condition, right, the answer we got differ, isn't it? So you can see that that property is not commutative and it's not closed as well. So which option carries the expression or such condition appropriately? So that should be option B, okay, neither commutative. Okay, so the binary operation is neither commutative nor closed on the set of positive integers. So option B is the correct option. 21. A binary operation on the real set of numbers excluding minus 1 is such that for all m(n), okay, shows a member of R. That's a real number, right? So then we have this expression. Find the identity element of the operation. Okay, so identity element is neutral element. Okay, the implication is just that if I have the identity element for this m, right? Okay, that means the answer should still give me n. That is, what number can I combine with m that will still give me this? All right, so if it is under the condition, let's say plus, right? Let's say something like this. So that will still give me m. So definitely that should be m minus m equals e. So that implies that 0 equals e. That is, e is 0, depending on the condition that we are given. So we are looking for that particular value or number that if we combine it to this particular one, right, for this expression, you should still get this value back. All right, so let's work with this expression we are given. So the implication right here would be m right to this, isn't it? Make this e. I'm just trying to bring this to us, right? me, that looks good. Okay, so let's see what value of e that we can impute, that by the time we bring all of this together, we'll still arrive at m. Okay, that means what we are looking for should still come back to m. All right, so let's look for that value of e. Let's assume that the value of e is actually 1. Let's see if it will come back to this. The neutral element, that's 1 times 1. So that will be m times 1, that is actually m, right? Then I have m plus 1. So at the end of the day, right here we have m, 2m, because m plus m, right? Oh, sorry, m times 1, that is actually m. Yeah, so I'll just have, okay, I have plus here. 2m plus 1, it did not give us m. So 1 is not the neutral element we are looking for. So let's try out 0. Okay, so that should be m plus 0 plus m times 0. Okay, so I should have m plus 0, that is actually m, plus m times 0, that is 0. So m plus 0, that is still 0. So the identity element for this particular expression is 0. So that means your e should be 0. Identity or neutral element should be 0. So let's see if we have 0 supplied in the options provided. Yeah, there's a confirmation. Option B is the right option. Number 22. In the diagram above, PQ is parallel to RS. PQ is parallel to RS. The size of the angle marked X is what? Okay, this is very easy. We just have to inculcate probably, corresponding angles, all those theorems, corresponding angles, vertical opposite angles, alternate angles, and the like. So the first thing we have to do, we have to pull off extensions from here. Okay, let's do that on our whiteboard. All right, so this diagram, we're going to work with this. So let's just do an extension like this, right? Then an extension like this. Okay, so this is just exuberant. All right, so look at this. This corresponds to this, isn't it? So this is also 50 degrees, right? Okay, if you look at this, this is vertically opposite. So that means here as well is 50 degrees. And this looks like a triangle. Look at this. This is actually a triangle, right? I have 30 here, 30. Here I have 50, right? Just this point here. Then I have here. So remember that sum of angles in a triangle is actually 180. So that means this place, 50 plus 30 plus the unknown, right? Okay, equals 180. That is 50 plus 30, that is 80. Plus y equals 180. So that is y equals 180 minus 80. That means angle y is actually 100. So this part here is 100. So that means the angle I have here is actually 100. So if here is 100, this corresponds to this place as well as 100. Do you see that now? Okay, so look at this, right? This is 100, this is x, isn't it? So you can see this is actually a straight line. Sum of angles on the straight line is actually 180. So that means the angle here should be 180. So that is x plus 100 equals 180. X equals 180 minus 100. So x equals 80 degrees. There are different ways to go about this, but I think this is the method. This should be relatable for us. So I have x equals 80 degrees. So the angle here is 80. So let's go back to the screen to secure 80 degrees. Very well, we have a confirmation. So option B is the correct option. 23. Find the exterior angle of a 12-sided regular polygon. Okay, so each exterior angle will just be 360 divided by the number of sides. So we have 12 sides here. So it's just 360 divided by 12. That is 30 per angle. Okay, so 30 degrees. So option D, 30 degrees, is the right option. 24. in the diagram above, we have angle OPQ is what? Okay, so no stress. Sum of angle in a triangle is actually 180. So this looks like an isosceles triangle. So that's here and here are equal. So I have 74. So 180 minus 74, that should give me 106. So if I split 106 into 2, right, because I'm looking for angle P, that is 53. So option B is the correct option. If you want to see some of the calculations or you want to see the workings, just click on the Myschool website. You are going to see this particular step. So you are going to see the steps well listed there. So option B is the correct option. Please be reminded that you can have a JAMB CBT simulated experience. All you need to do is to click on the link in the description below. This is going to get you to the Myschool website. Right there you get to download the Myschool mobile app for your Android devices, or you can go for the Myschool software for your laptops, your computers. So join me as I solve question 25. Find the area of the figure above. So you can see this figure, it's like a combo, right? I can sort out a rectangle this way and also a semicircle. All right, rectangle to semicircle. So I will just find the area of these individual figures, then match the answers. Okay, so for the rectangle, I have something like this. You know, I have 5 centimeters, then I have 15. Then the semicircle, all right, this looks somewhat funny. 5 centimeters. Right, okay, so right there for the area of a rectangle is length times breadth. So that's basically 5 times 15, and that amounts to 75 centimeters squared. All right, so let's come to the semicircle. So you can see this entire width represents your diameter, right? I remember that diameter is actually 2r. So if the diameter is 5, that means the radius will be 5 over 2. Isn't it? So the area of a semicircle is actually 1 over 2 times pi r squared. Okay, so I have 1 over 2 times pi, which is given as 22 over 7 from the question. Then I have my r, which is 5 over 2 times, right? 5 over 2 times 5 over 2. Okay, so right here I should have 22 times 25 over 2 times 7, that is 14. 14 times 2, that is 28. 28 times 2, that is 56. All right, so by the time I divide this, I should have somewhat around, I think 9.8 thereabouts. Okay, so if I had 9 point something to this, I should have somewhat around 84.82. 821 centimeters square, so roughly 84.8, or if you want to round it up, I can have 85, well basically 84.8. All right, so let's go back to the screen to sort out this value. I think we have a confirmation. Option D is the correct option. Please do not forget to motivate us by hitting the like button. Also, don't forget the subscribe button, and always tap on bell notification for you to get alerts immediately we upload the next video content just for you. 26. Find the angle subtended at the center of a circle by a chord, which is equal in length to the radius of the circle. Okay, so let's break this down. So the angle subtended at the center of the circle by a chord. So as the chord passes through the center of the circle, it becomes a diameter. All right, so but there's now a specification which is equal in length to the radius of the circle. So at first, passing through the center of the circle, let's just assume it's a circle, it's now cut it into 2. Okay, that means 180, 180. But right now we are now told that the length of the chord is actually equal to the radius of the circle. And we know that radius is half of diameter, isn't it? So diameter is actually 180, radius will just be 60. Do we see that now? So 60. So the angle there should be 60 degrees. So option C is good to go. 27. Find the capacity in liters of a cylindrical well of radius 1 meter and depth 14 meters. Okay, so let's walk around this. So we can just, the difference between volume and capacity. I think one of the differences, okay, you can tell that volume is actually the amount of space occupied by an object, a 3-dimensional object, to be specific, probably a container, a solid, right? Then capacity is talking about how much of liquid or pourable substance that particular container can hold. So let's just interchange this to make this work easier. So we record that the volume of a cylinder, right, it is base area times height, or you can say area times height, or you can just say pi r square h. Okay, this is height. Okay, then we are given pi as 22/7. Then the radius that we have right here, we are told radius 1 meter. So I'm just going to write this out as this. This is 1 meter is the same thing as 1,000 centimeter, isn't it? So I have it right here. Then I have times, or I can just write 1 meter, then I come back to convert later. Okay, I can do my conversion later. So I'm working in meters right now. So I have times 1, right, times, okay, that is 1 raised to power 2, times the height of the well, that is depth, that's 14 meters. Okay, so I have 22 times 1 times 1 times 2. 22 times 1, that is 22. Times 1, that is 22. Times 2, that is 44. So I have 44 meter cube. So if you recall that this, right, equals to 1,000 liters. Remember, we're asked to present our answer in liters. Therefore, 44 meter cube is equals to x. So by the time we cross multiply, we have x times 1 equals 44 times 1,000 liters. So that should be 44,000 liters. So let's go back to the screen to select 44,000 liters. All right. So take note of the units that you work with. So we can run a confirmation right here. So option A is good to go. 28. The locus of a point equidistant from 2 points P, 6, 2 and R, 4, 2 is a perpendicular bisector of PR passing through where? Okay, so we look at this perpendicular bisector. All right, so we are not able to find the equation. So this is where our focus is. So this is very, very easy. Okay, so we have 2 points, right? P, that is 6, 2, then I think R, yes, that is 4 and 2. X1, Y1, X2, Y2. All right, just use this simple formula. X1 plus X2 over 2, then Y1 plus Y2 over 2. Okay, so we have X1 as 6 plus Y1, that is 4 over 2. Then we have Y1, that is 2 plus Y2, that is 2 over 2. Oh, please. Over 2. Okay, so 6 plus 4, that is 10. 10 over 2, that is actually, okay, I have 10 over 2. All right, sorry. I think I'm quite fast. 2 plus 2, that is 4 over 2. Right. Okay, then that implies 10 divided by 2, that is 5. 4 divided by 2, that is 2. So this is what we are looking for, 5 and 2. So let's go back to the screen to carry out specification. Option B is good to go. Question 29. Find the gradient of a line which is perpendicular to the line with the equation 3x plus 2y plus 1 equals 0. So gradient of a line, then perpendicular. All right, so let's take it step by step. First, we have this equation, 3x plus 2y, right, plus 1 equal 0. Right, okay. So remember this, y equals mx plus c. That means that we have to rearrange this to look like this. So where do I have my y? I have my y somewhere. So that should be, that means my y is like this, right? So then my x should be inside. So let's say the y is not moving, right? It's static. So I should have something like this, 2y, right, equals mx, which is 3x. So if the 3 goes outside, it becomes minus, right? Okay, then I have plus into brackets, plus 1, if it goes outside, then I have minus. So this means that this is 2y equals minus 3x minus 1. Plus times minus, that is minus. So this is intercept, this is the gradient, but not yet. All right, so we are looking for y, not 2y. So we're going to divide both sides by 2, right? By 2, by 2. Okay, so I have my y equals minus 3 over 2x, right? Minus 1 over 2. So definitely this is my m, right? My m1 is actually minus 3 over 2. So when it comes to perpendicular, we are talking about perpendicular, for it to happen, that means m1, m2, that is my first slope, my other slope, okay, should be equals to minus 1. So if I'm to look for m2, what do? I divide both sides by m1. Right? So this implies that minus 1 divided by, what is my m1? That is minus 3 over 2, right? So if I want to change these 2 times, that would just be minus 1 over 1 times minus 2 over 3. So I have minus 1 times minus 2, that should give me, okay, that should give me plus 2 over 1 times 3, this is it. So this and this, they account for the condition of being perpendicular. All right, so we see this, okay? Yes, this to this. All right, because if you multiply these 2, it should give you minus 1, right? If you want to check, you can, okay, let's carry out a check. Check. I think this solving looks like a map, treasure map. Okay, so I should have this m1, m2. Let's see if it will give me minus 1. So what is my m1 again? It's minus 3 over 2 times m2, 2 over 3, right? This is 1, this is 1. So at the end of the day, minus 1 times 1, I have minus 1 over 1 times 1. So we see minus 1. So it's very valid. So let's go back to the screen to point out 2 over 3. Very well. Option B is good to go. Please be reminded that you can ask your questions right now. All you just need to do is to click on the link in the description below. This is going to get you to the Myschool website. Right there, you get to interact with our solution providers. You ask your questions, you get clarity. So why not try that on the spot? So join me as I solve question 30. If sine theta equals 3 over 5, find tan theta. Okay, so this is very easy. So we call our SOHCAHTOA. I think we are going to need this. It should be very handy. Okay, sine, cosine, and tangent. Okay, so I have sine theta is actually 3 over 5. So sine is opposite over hypotenuse. So I have opposite right here, then my hypotenuse. So we're asked to look for tan, but we recall that tan is actually opposite over adjacent. So we don't have adjacent. So how do we do that? We can reintroduce Pythagoras theorem. Okay, so we have this hypotenuse square equals opposite square plus adjacent square. All right, so right here we are looking for this. All right, so this can come first, whichever one. Okay, so that will be adjacent square, right, equals hypotenuse square minus opposite square. Okay, so hypotenuse is actually 5. So 5 square is 5 raised to power 2, and that is 5 times 5. That accounts for 25, right? Minus opposite is actually 3. 3 raised to power 2, that is 3 times 3, that is 9. So 25 minus 9, that is 16. So that means adjacent square equals 16, right? So to eliminate this square, what do? We can do a square root of both sides, right? So adjacent equals square root of 16, that is actually 4. So our adjacent is 4. Right now we can now find tan theta. Okay, so that means that tan theta is actually what? Opposite, right, over adjacent, and that is simply opposite is 3 over adjacent. We've gotten that as 4. So tan theta is actually 3 over 4. So let's go back to the screen to select the option with 3 over 4. Not this, of course. Option A is the correct option. It is very possible that you have better steps, solutions, or explanations to share. Please, we are so much interested. All you just need to do is to kindly use the comment section below, indicate the question number and the solutions or steps you'd like to share. Number 31. Find the derivative of y equals x raised to the power 7 minus x raised to the power 5 over x raised to the power 4. Alright, so we can use indices to solve this. Okay, so I can do a split. Right. Okay, let me just use the basic method to solve this. So this is actually x times x minus then this. Okay, so I have, how many do I have left? 1, 2, 3, right? Okay, then from here left with 1. All right, do we see this then? So from the question, we are asked to find the derivative of y equals this. So if we differentiate here, so this would be x, this would be 3, right, times x raised to the power 3 minus 1. Then we have this minus, this is 1 dot x raised to the power 1 minus 1. So this is definitely 3 minus 1, that is 2. So this is 3 times x raised to the power 2 minus 1 minus 1, that is 0. X raised to the power 0, that is 1, times 1, that is 1. So this is the derivative we are looking for. 3x squared minus 1. So let's go back to the screen. 3x squared minus 1. Of course, we have a confirmation here. Option C is the correct option. Question 32. Differentiate sine x minus x cos x. All right, so let's do this together. Okay, so when you differentiate trig functions, okay, so we have, like, for instance, when we differentiate sine x, gives us cos x, right? So when we differentiate cos x, it gives us minus sine x. Okay, so let's work with this provision. Okay, so we have sine x. So when I differentiate this sine x, what do I have? Already I know I have cos x. So let me deal with this first. So if I extract this out, right, so right here I can use the product rule. Okay, I can identify this as u, can identify this as v. Okay, all right, u and v. So remember product rule, right? The y dx equals v du dx plus u dv dx. All right, so the first part is that I'm going to leave this, then differentiate this. Okay, whichever one I want to start with. So that means u, right, times, if I differentiate this, cos x, it will give me what? Minus sine x. Okay, sorry, u is actually x. Sorry, x, right, times, when I differentiate cos x, it gives me minus sine x. Isn't it? Okay, that's perfect. Then I have, okay, let me just put times, plus the other side, this will be left alone, v du dx, cos x, times, if I differentiate sine x, that is actually 1. If I differentiate x, rather, that gives me 1. Okay, so cos x times 1, that is actually cos x. Right? Then this is minus x sine x. Isn't it? Okay, so that means I'm going to replace this. Right. Okay, so remember, if I differentiate this sine x, it will give me cos x. So that will be cos x, right, minus this, after it has undergone operation. So I have minus x, right, sine x, right, then I have plus cos x. By the time I open up the brackets, minus times minus, this becomes plus. Okay, so let me just collect like times to shorten the process. So I have minus times plus, this is actually minus cos x. Then we have minus times minus, then we have plus x sine x. So cos x minus cos x, that is actually 0. That's gone. So what I'm left with is x sine x. So the derivative of this is this, x sine x. So let's go back to the screen together. Okay, x sine x. So option B is the correct option. Question 33. So we are asked to find the minimum value of the function y equals x open parenthesis 1 plus x close parenthesis. Okay, so I have this. So at first, I have to expand my brackets. I have x times this plus x squared. So right here I differentiate. If I differentiate this, it's going to give me 1 plus, if I differentiate x raised to power 2, that will give me 2x. Alright, so we proceed. Then we'll bring it to 0. Okay, let me just say equals 0. So if this comes out, it becomes 2x equals minus 1. Dividing both sides by 2. So I have x equals minus 1 over 2. Okay, so we're asked to sort out the minimum value. Okay, I'm just going to work with this because this is the value that we can derive from this expression. Okay, so that will be y equals, anywhere we see x, we replace it by minus 1 over 2. So that is minus 1 over 2, or I can use it from here, whichever one is convenient for us. Okay, so, okay, let me decide to, if I use it from here, it's still fine. So I have minus 1 over 2, using it from here, okay, plus, into brackets, minus 1 over 2 raised to power 2. That implies that minus 1 over 2, right? This one here, that is minus 1 over 2 raised to power 2 means minus 1 over 2 times minus 1 over 2. So minus times minus, that is actually plus. 1 times 1, that is 1 over 2 times 2, that is 4. So this should give me plus 1 over 4. So what do? We find the LCM, which is 4. So 2 in 4, that is 2. 2 times minus 1, I have minus 2. Plus 4 in 4, that is 1. 1 times 1, I have 1. So minus 2 plus 1, that should give me minus 1 over 4. So this is the minimum value based on this provision that we can get. So minus 1 over 4. Let's go back to the screen for minus 1 over 4. So option A carries the right value. We've come to the end of this video lesson, and definitely you know that there are more videos to come. All you just need to do is to always hit that like button for us, and do not forget the subscribe button, and always tap on bell notification for you to get alert immediately we upload the next video content just for you.